Hi, I'm Kian, and in this video I'm going to show you how to solve a linear non-homogeneous differential equation. So here we have our differential equation, dx dt plus x over 3 is equal to 20 plus 2t. So here we have a function of x, which is in terms of t, it's a one variable function, and we want to solve for the function x. So what do? So for solving linear non-homogeneous differential equation, there are basically two tricks to do this. So the solution set of this, which I'm going to call x of t, is going to be made up of two parts. One part is going to be the particular solution. I'm going to call x sub p. And the next part is going to be the homogeneous case, x sub h. So let's go to the easier part, which is the homogeneous case. So a homogeneous differential equation, a linear differential equation, is basically when the left-hand side is equal to 0. So if we had instead of 20 plus 2t 0, then this would be a linear homogeneous differential equation. So one part of our answer would be actually the solution to the homogeneous equation, which is also called the characteristic equation. So what we have is part 1. So we have dx dt, which I'm going to call x prime, plus x over 3 is equal to 0. Now, for solving this, either we can actually use separation of variables, but I'm going to introduce something called the characteristic equation, or the characteristic solution, which in this case, I'm going to say that x of t is in the form e to the rt. Now, if we differentiate, since we want to plug it in and solve for x of t, so the derivative of e to the rt would be r e to the rt plus e to the rt over 3, and this equals 0. So we can actually factor out e to the rt, and we can see that r in fact equals negative 1/3. So very easily and very quickly, we can see that the homogeneous solution, x of h, is actually e to the negative 1/3 t. However, because we want to basically generalize it, I'm going to stick to it a constant. So c1 e to the negative 1/3 t. So using constants is very kind of a trivial thing in differential equation, and also integration. We add a constant, but also when we want kind of a general solution, we always have to have the constant. Since sometimes we are given initial conditions, which also help us to solve this constant. So now we've basically halfway done, we're 50% done. So the next part of the solution would be the solution to x of p. So part 2 would be the solution to x of p. And that is basically a way of solving it is called undetermined coefficients, in which the only way we can really do this is basically guess and check. So what we do is that we take a look at our original equation. So we have dx dt plus x over 3 is equal to 20 plus 2t. And we think to ourselves, what kind of function would we have if we take the derivative of it once and then add it to 1/3 of it, we get a linear function 20 plus 2t. And if you said the function should be linear, you're in fact correct. Because if we have a linear function, let's say in the form of mx, in this case mt plus b, if we differentiate it once, we get a constant, and then 1/3 of it would be also another linear function. So in this case, it will kind of balance it out with what we have on the right-hand side. So that's what's called the undetermined coefficient. So we kind of have to guess the formation of the function or the particular solution in this case. So we define our x of p, I'm going to change colors to blue, to be in the form of linear. So mt plus b. So this would mean that our equation, so if we differentiate it once, we just get m plus 1/3 mt plus b over 3 is equal to 20 plus 2t. Now we can actually match the coefficients and constants, so we can see that we have only one term in terms of t here, and same in the in the right hand side. So 1/3 m has to equal to 2, which means that m is in fact equal to 6. And if m is equal to 6, then m plus b over 3 must be 20. And if m is 6, then b over 3 must be 20 minus 6, or 14. So b is 42. And so we have actually found the xp, or the particular solution to this differential equation. So it would be 6t plus 42. And so our final solution to this problem would be x of t, which is the sum of